All right, let's dive into the I in solid, the interface segregation principle. And trust me, once this one clicks, you're going to start seeing ways to clean up code absolutely everywhere.
So, to really get a feel for this, let's start with a little analogy. Picture this. Someone hands you this monster of a game controller. You know the type. It's got 20 buttons, a couple of joysticks, triggers, the works. But the game you're playing, it's super simple. All you have to do is move left and right. All those extra buttons, they're not just useless. They're clutter. They make a simple job feel way more complicated than it needs to be.
And that exact feeling, that feeling of being weighed down by a bunch of tools you don't actually need, that's precisely what the interface segregation principle helps us avoid. So, how does this kind of clutter and complexity show up in our actual code?
Okay, so here's our roadmap for today. We're going to kick things off by identifying the problem of unnecessary burden. Then we'll lay out the rule to fix it. We'll walk through a classic printer example and a real-world API design scenario. After that, we'll get into why this all really matters, and we'll finish up with one simple question you can use to spot these issues in your own work.
So the main bad guy in this story is something we call a fat interface. You've probably seen these before. It's what happens when we create one single, massive interface that's supposed to do everything for everyone. It might seem like a good, efficient idea at first, but believe me, it quickly becomes a huge pain. Now, the solution, thankfully, is really elegant and super powerful. The Interface Segregation Principle. I mean, the name pretty much gives the game away. We need to segregate or break apart our interfaces.
The official definition is perfectly clear. No class should be forced to depend on methods it does not use. If a class says it's going to implement an interface, it shouldn't have to write a bunch of boilerplate code for methods that have absolutely nothing to do with what that class is supposed to be doing.
All right, enough theory. Let's make this real. We're going to use the classic printer example to see exactly how a bloated, clunky design can be transformed into something clean and, brilliant.
So first up, the problem. Imagine we've got this one giant fat interface called iMultifunction device. And as you can see, it's designed to do it all: printing, scanning, and faxing. Now, for a big all-in-one office machine, that seems pretty logical, right? What could go wrong?
Well, here's what goes wrong. What happens when we want to represent a simple, old-school printer, one that can only print? To use our interface, the simple printer class is now forced to deal with scan and fax, two methods it has no idea how to perform. This leads to all sorts of messy workarounds, like leaving the methods empty or, maybe worse, throwing an exception. This is a huge code smell and a textbook violation of the interface principle.
And the solution? It's just so much cleaner. We break that one fat interface into three small specialized ones: an iPrinter, an iScanner, and an iFax. Now our powerful multifunction printer can go ahead and implement all three of them. But our humble, simple printer, it only needs to care about one thing: implementing iPrinter. Perfect.
And the payoff here is immediate and just so satisfying. Every class only implements the functionality it actually has. We completely get rid of those ugly empty methods and those dangerous exception hacks. Our code is instantly cleaner, more logical, and frankly, just easier for anyone to read and understand.
Okay, so this principle isn't just for some hypothetical printers, of course. Let's apply this exact same logic to a very common, very real-world scenario: designing a back-end API for a user service.
Over on the left, you've got the bloated approach. One giant iUser service that has methods for, everything. Admin actions, report generation, user data, email notifications, you name it. So now a simple email service, which only cares about user emails, is suddenly forced to know about admin functions it will never ever use. Now look to the right. This is the segregated API. Each client, whether it's the admin panel, the reporting tool, or the email service, gets its own tiny, specific interface. It only depends on the exact methods it needs. So much better.
So why do we go through all this trouble? What's the big deal? Well, the real gain here goes way beyond just having nice, tidy-looking code. Following this principle fundamentally improves the entire structure of our systems.
The number one reason, the absolute biggest win of the interface segregation principle, is achieving something called loose coupling. And all that means is that the different parts of your system aren't all tangled up together. A change you make in one component doesn't create this cascade of failures and required changes across totally unrelated parts of your application. And when you achieve that loose coupling, you get a whole bunch of amazing benefits. You slash all those unnecessary dependencies. which makes your code way more flexible and so much easier to maintain down the road. And here's a huge win for all of us developers. Testing becomes dramatically simpler, because now you can work with small, focused mock objects instead of these huge, complicated ones that try to do everything.
Now, this is a really important point because it clears up a common bit of confusion. People often mix up ISP with SRP, the single responsibility principle, but they're different. SRP is all about a class having only one reason to change. The question there is, what should this class do? ISP, on the other hand, is all about the interface itself. The key question for ISP is, how big should this interface be? They work together for sure, but they focus on different parts of the design.
Okay, so let's wrap this all up with a simple, actionable takeaway. Think of this as a quick litmus test you can use in your day-to-day work to spot these exact problems.
So when you're looking at your code, or maybe doing a code review, how do you know if you've stumbled on a violation? What's that big red flag you should be looking for?
You just have to ask yourself one critical question. Does this class really use all of the methods that are defined in the interface it's implementing? If the answer is no, if you see empty methods, if you see exceptions being thrown for unused functions, then you have almost certainly found an ISP violation. It's that simple.
Ultimately, it all just boils down to this one powerful idea. Don't depend on a method you don't use. By keeping your interfaces small, focused, and tailored to their clients, you build software that's more robust, more flexible, and so much easier to maintain. So think about it. What part of your own code base could benefit from a little interface segregation?